Welcome to 9.6 Notes, Secants, Tangents, and Angle Measures. A secant is a line that intersects a circle at 2 points, and line AB is a secant of circle O. So if you take a look, you see I have line AB. This intersects circle O at 2 points. When two secants intersect inside a circle, the angles formed are related to the arcs they intercept. So theorem 9-12, if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angles. So here, angle 1 is equal to half the measure of arc AB plus arc DC. Angle 2 is half the measure of arc DA plus BC. So let's take a look at example number 1. It says I need to find the value of x. Well, if I take a look, I'm going to see that x is equal to 1/2 the measure of the two arcs that it swoops out, 88 plus 76. So I could do a half of each one of these and then add them together, or I could add the parentheses. So half of 164, I get x is equal to 82 degrees. Looking at example number 2, I could find the measure of angle WZX. That's what they want me to find. So WZX is where x degrees is. But I'm kind of in a difficult spot because I don't know. So I do know one thing. I do know that 96 and 62, I could add those up, and that could give me this angle's VZW. Again, if I take and add 96 and 62, I could get this angle right here, or I could get this angle right here. So 96 plus 62, so we'll call that y is equal to 1/2 of 96 plus 62. If I do that, I'm going to get 158. And half of the 158 is going to be 79. So that angle right here is 79 degrees. Then I could think, well, these form a line, so x degrees is equal to 180 minus the 79, which is 101 degrees. You could have said, all right, well, I know that 96 and 62 is 158. So if those two angles add up to be 158, I could say, well, arc XW plus arc YV plus 158 has to equal 360. And you know that arc XW plus YV is equal to 360 minus the 158. And if you do that, you get 202 degrees. So you could have said half of 202. And that will give you 101 degrees. I don't care how you approach that problem. Same thing right here. Find the measure of x degrees. So I'm just going to say 68 plus 102. 68 plus 102 is 170 degrees. I could then find half of that. That will give me the angles right here. But I'm just going to do what I did last time. I'm going to do 360 minus the 170. If I do 360 minus the 170, I'm going to get 190. So that means the measure of PO plus arc MN, that is equal to 190. So half of 190. And when we do that, x degrees is equal to 95 degrees. And lastly, here I know that 67 degrees is the measure of my central angle. That is equal to 1/2 of 30 plus x. Well, in order to get rid of that 1/2, I could times everything by 2. So that will cancel out. 2 times 67, that is 134 is equal to 30 plus x. I subtract the 30. 104 degrees is x. So recall from previous notes, the measure of an inscribed angle is half the measure of its intercepted arc. If one of the sides of the angle is tangent to the circle, the relationship still holds true. So this leads us to theorem 9-13. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So I need to find the measure of angle QPS in example number 1. So here is angle QPS. If I see, here is the intercepted arc. We know it is 250 degrees. So the measure of angle QPS is 1/2 of 250. So if I take half of 250, that is 125 degrees. Here I need to find the measure of angle B, I need to find the measure of arc BCD. So arc BCD right here. Well, I know that angle ADB, right here, this angle is 108. So that means arc DAB is 108 times 2. So 108 times 2, that's 216. So now I have to do 360 minus the 216, and you're going to get 144. What is the measure of angle FGI? That is 1/2 of 225. So if I do that, I'm going to get 112.5 degrees. If that's 225, I know that all circles add up to 360, so you could do 360 minus 225. If I do 360 minus 225, you're going to get 135. And if you do 135 divided by 2, you're going to get 67.5 degrees. Here I need to find the measure of arc UVW. Again, I got my central angle, or this inscribed angle, intercepted arc is what I need to find next. So the 99 times 2, that's going to give me the measure of arc UTW or UW. So 99 times 2, that is 198. So I'm going to do 360 minus 198. You get 162. So we're finished. Sometimes secants and tangents can meet outside of a circle. The measure of angle formed also involves half the measures of the arcs they intercept. So what we're going to do is look at theorem 914. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So here I have two secants. Notice they meet point A outside the circle. So this angle DAE, or angle A if you will, is 1/2 the big arc minus the small arc. If I have a secant and a tangent intersecting at point A here, then again angle A is 1/2 the big arc minus the small arc. If they're two tangents, angle A is 1/2 the big arc minus the small arc. So let's take a look at example number 1. Example number 1, they're asking me to find the small arc. So setting up, I got to use my formula here. 62 is equal to 1/2. The big arc, if I look, is 141 minus arc BC. So all I have to do is multiply both sides by 2. So 162 times 2. Why? I've got to get rid of this half. So I'm going to get 124. So 124 equals 141 minus arc BC. I subtract the 141 from both sides. You get negative 17 equals negative arc BC, so arc BC is 17. Moving on to the next example. This one, they want me to find arc X, Y, Z, so they want me to find the big arc. So I'm going to say that 40 is equal to 1/2 the big arc, unknown. I'm going to call that X, minus 140 the small arc. So here you times both sides by 2. 80 equals X minus 140. I'm going to add the 140 this time. And we get that 220 is equal to X. Now, somebody could have said, Mr. No, that's pretty easy. If this is 140, and we know all circles add up to 360, couldn't you have said it was 220 right away? Yes, I could have. All right. Here, again, I need to find the measure of the small arc. So 56 is equal to 1/2 135 minus 56. Pardon me, minus the small arc, QS. Times it by 2. We get 112 is equal to 135 minus arc QS. Subtract the 135. We get negative 23 equals negative QS for the arc, which means the measure of arc QS is 23. And lastly, again, I need to find the measure of arc FIH. I could use that formula. So 360 minus 130, that is going to be 230. So this last page here just summarizes our angles. So if the vertex is on the circle here, and all we have to do to find angle 1 is take half the measure of the intercepted arc. If it's inside the circle, angle 1 is half the sum of the two intercepted arcs. If it is outside the circle, angle 1, it is half the difference. I hope you found this lesson helpful and easy. Please check the homework on Schoology, and good luck.